Alright, let's take a look at question 9. Claire poured 200 cm cube of water into each of the 4 bowls A, B, C, and D. The 4 bowls were made of the same materials but of different exposed surface area. She then placed 3 of the bowls on table in the science room and another bowl under the sun. So one of the bowl is being placed under the sun. So in this case, you see our exposed surface area is actually our change variable, okay, indicated in blue here. And the amount of water being used and the material used for the bowl, they are actually our constant variable, which is as indicated right here, okay. So our constant variable is our same type of bowl and the same amount of water being used. However, there's one bowl that's being placed under the sun, while the rest of the 3 bowls is in the science room, which is at the room temperature. So we have 4 bowls here, A, B, C, D. So the exposed surface area, as it was increasing from 20 to 40 to 60 to 80, and this is what we mean by our change variable here. This is our change variable. So as the exposed surface increases, okay, let me write out here. As the exposed surface area increases, the rate of evaporation should be faster. Okay, it means the rate of evaporation should be higher. So our rate of evaporation over here, it should be higher in this case. So we take a look at the number here. The remaining of water here is actually our measured variable, which is as indicated here. You see, a few hours later, she measured the volume of water left. So the volume of water left is actually our measured variable. So you see the measured variable, as the exposed surface area increase by right, the volume of water remaining, it should be the least amount, because it means that when the exposed surface area is higher at the greatest, the evaporation rate, it should be highest as well, because we know that this is one of the factors that affect our rate of evaporation. So the volume of water by right, it should be the least amount, as we see that the exposed surface area increase, the rate of evaporation should be lower. But can you see that this number 164 here? Okay, let me highlight in, perhaps highlight in this color green. You can see that it's actually the same number as bowl D. So to make you see easier, let me draw a box for you. So this one here. Okay, let's take a look at bowl B, C, and D. When the surface area is increasing, the exposed surface area is increasing, the rate of evaporation should be increasing, which means that the volume of water left in the end should be the least amount, okay? So from here, exposed surface area increase, the rate of evaporation actually increase also. So the volume of water left at the end should be decreasing, like here, 173 to 170 to 164. So it should be decreasing here, like here. It should be the least amount, this amount. But for bowl A, you can notice that the volume of water remaining is the same as D. So it means that for this bowl, bowl A, this should be the bowl that's being placed under the sun. That cause the rate of evaporation should be so much higher, even though the exposed surface area is so much lower. So our answer for this case will be our bowl A, which is number 1. So number 1 will be our answer for the one that is being placed under, the only bowl that's being placed under the sun. Hope you understand better now.